Hi, I'm Gary Rubenstein, and in this video I'm going to show you how to solve various cubic equations. In high school, you learn how to solve linear equations, and you learn how to solve quadratic equations. And then when you're up to this next step, solving cubic equations, you do very little with that. Maybe there are some situations where you could factor a cubic, but in general, you don't learn how to solve cubic equations, and most people never learn how to solve them. Well, in history, in mathematical history, they figured out how to solve quadratic equations back in 1500 BC. But cubic equations were not cracked until 3,000 years later. In the year 1545, a man named Cardano published a book called Ars Magna, in which he showed how to solve cubic equations and even put in how to solve quartic equations. So let's take a look at an example of a cubic equation. So what makes it a cubic equation is this exponent there. And this cubic equation, which does not have an x squared term, is one of the easier types to solve. Now, just if you look at this question, well, there definitely is an answer, because if you put 0 in for x, well, that wouldn't be true. 0 cubed is not the same thing as 9 times 0 plus 28. The right side is definitely bigger. But if you put a large number in, like 10 cubes 1,000, well, that's a lot bigger than 9 times 10 plus 28. So somewhere between 0 and 10, there is going to be a number that makes the left and right side equal to each other. And if you mess around with trial and error, you would find that when x equals 4, it would be true that 4 cubed, which is 64, would equal 9 times 4 plus 28, which is also 64. So if there's an integer answer, you might get it through some kind of trial and error. But usually, cubic equation does not have an integer answer. Normally, it's got some sort of irrational answer. So we need a better method than just trial and error. And for equations of this form, first I'm going to show you that there is there's a formula. I'm going to show you the formula first, and then afterwards show you where this formula comes from. But first I just want to show you that there is a formula, and this formula was published in the mid-1500s. The formula is for equations of the form like this: x cubed equals something x plus something. And the formula is pretty unusual looking. It's the sum of two cube roots. Each cube root itself is q over 2 plus the square root of q over 2 squared minus p over 3 cubed. And the second cube root thing is almost the same thing there, except there's a minus there. So that's like the formula. That formula is often called the Cardano Formula, even though it was discovered by someone else about 30 years before that. Let's just see that this works for this example. So according to this formula here, x should equal the cube, I'm going to write over here, q over 2 is 28 over 2, which is 14. That's going to go here and here. That should be minus. That's plus. And inside this square root, that's going to be q over 2 squared minus p over 3 cubed. So I'm going to actually work out q over 2 squared, which is 196. 14 times 14, and then p over 3 cubed equals 27. So inside here, if I subtract 196 minus 27 equals 169, and that's what goes here and here. So that's a pretty ugly looking expression, and often you have to leave it like that. You can't go any further with it. But sometimes you get lucky in that the thing inside the radical, in this case, is a perfect square. And we're going to combine and simplify more, and sometimes you get even more lucky that this expression inside the cube root ends up being a perfect cube like it is here. And at least for this example, this formula works. Now the formula sometimes doesn't work as nicely. Like imagine my equation was x cubed equals 6x plus 40. Well, according to the formula, we need three calculations. 40 over 2 is 20. 40 over 2 squared is 20 times 20, which is 400. And 6 over 3 cubed is 2 cubed, which is 8. And 400 minus 8 is 392. So according to the formula, this 20 goes here and here. There's a plus, there's a minus, there's a square root, there's a square root, and inside the square root goes this number here. Now, unlike before, we don't get lucky. 392 is not a perfect square, so I can't take the square root of it, and I kind of have to leave it like this, which is unfortunate because if you did trial and error on the original equation, you would find that the answer is 4. 4 cubed is 64, and 6 times 4 is 24, plus 40 is also 64. Now, cubics could have more than one answer, but in this case, if you were to actually type this big expression into a calculator, it actually does equal 4. It's just a 4 written in a really unusual way. And there's not an easy way to simplify it, but still, if someone asks you, what's the answer to this question, you wouldn't be wrong if you told them it was this big expression, because that is a fancy way of saying 4. Now, the derivation of this formula is a little bit complicated, and if you're not interested in the derivation of it, you can skip ahead to the part where I'll show you how to solve cubic equations that do have a squared term. But I do want to show you the derivation. Let's go back to that x cubed equals 9x plus 28 question. Now, the trick to this is to say, well, rather than solve for x, let me just, maybe if I split x up into two pieces, which I'll call a and b, there'll be some way of getting a and b separately and then combining them to get the x. Well, if x equals a plus b, then x cubed equals a plus b cubed. And maybe you already know that a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. Or maybe you don't know that already. But you probably know that a plus b times a plus b is a squared plus 2ab plus b squared. Then you multiply that times a plus b. You can first multiply all three of these terms by a. Then multiply all three of these terms by b. I'm going to put the like terms under each other. And then when you combine those six things, you get this expression. Well, this expression, I can rearrange the four terms. And then something very lucky happens. These first two terms have a common factor of 3ab. And if I factor it out, I end up with a plus b, and this a cubed plus b cubed stay there. And the clever insight is that, remember how x was a plus b? Well, that a plus b appeared here, so I can replace it back with x. And look at what I have here. This resembles this equation up here. In other words, it's x cubed equals something times x plus something. So the long way of doing this question would be to say, well, if my equation is x cubed equals 9x plus 28, is the 3ab has to be 9, and the a cubed plus b cubed has to be 28. So solving this equation is equivalent to solving the system of equations 3ab equals this number, and a cubed plus b cubed equals this other number. And a and b are going to end up becoming 1 and 3. And when we add them together, we're going to get 4, which is the answer, because x is a plus b. So you solve the system of equations, and then you add together the two answers you get, and you'll get the solution, or one solution to the cubic. Well, let's say it's not easy to solve this system of equations by trial and error, you could use substitution. I would divide both sides of this top equation by 3a. And in the bottom equation, I would substitute 3 over a for b. Now this bottom equation, I could simplify a little. And then I can multiply both sides by a to the third. And then I can bring everything over to one side. And this is a 6th degree equation. And let's say I have enough trouble solving cubic equations. But in this case, if a 6th degree equation has no x to the 5th, x to the 4th term, or x squared term, it just has these 3 terms. In general, if this exponent here is double this exponent here, we can rewrite it as a cubed squared minus 28 a cubed plus 27. If you watch the quadratic equation, the part 1 of this, you can see this is like u squared minus 28 u plus 27 equals 0. Now, quadratic equation sometimes can be factored. In this case, it can. So if we can factor it, we might as well. A cubed minus 27. So a cubed equals 27. A equals 3. Or a cubed equals 1, a equals 1. Now remember, in our substitution, b was equal to 3 over a, or even easier, sorry, we can go up to this guy. A cubed plus b cubed equals 28. So once I have a calculated, this would lead me to b equals 1, and this one would lead me to b equals 3. So either my answer is a is 1 and b is 3, or a is 3 and b is 1. It doesn't matter which one you use because x is a plus b, and regardless of which one you use, 1 plus 3 equals 4. So this is a very long way of doing it, using the system of equations. This here is like a one-time demonstration about why you could solve equations like this by creating a system of equations. So I'll sort of summarize there. If my equation is x cubed equals px plus q, if I solve the system of equations 3ab equals p, a cubed plus b cubed equals q, and once I solve for a and b, I can just add the two answers together. So that's sort of a longer way of doing it without the formula. Now in this last example, this 6th degree equation here ended up factoring. That doesn't have to happen. What if my equation was x cubed equals 6x plus 40? And I wanted to use the 3ab is equal to 6, a cubed plus b cubed equals 40 strategy. Substitution, I would say b equals 6 over 3a equals 2 over a. which means when I substitute that b in for the b in the b cubed equation there, equals 40, becomes 8 cubed plus 8 over 8 cubed equals 40. Multiply both sides by 8 cubed, get 8 to the 6 plus 8 equals 40 8 cubed. Bring everything over to one side. Now we have the 6th degree equation that's got only a 6th degree and a cubic and a constant, so it can turn into something like that. It's like a quadratic. I'll just say this is like u squared minus 40u plus 8. Now that one doesn't factor, so you'd have to use the quadratic formula. If it was this equation on the right, you would get negative b plus or minus. I'm just going to use the plus because we only need one answer, and then we need to get like what a is, and if we get a, it would lead to a b value, but if I get the other a value, that will end up being what the original b value was, so it doesn't matter. So I will let you use the quadratic formula here, but just do a plus. B squared minus 4ac. Inside this radical will be 1,568. That's b squared minus 4ac, 1,600 minus 32 over 2a. Now, what works out nicely is that this 1,568 is actually divisible by 4. It's 4 times 392. And that lets me go even further because the square root of 4 is 2. And finally, I can divide both terms by 2. And get this answer for . Now, so that means if I come over here and did the same thing, I'd end up with not u equals, but the a cubed is kind of taking the place of the u. So it would end up a cubed is 20 plus the square root of 392, which means a is equal to the cube root of 20 plus the square root of 392. Now to solve for b, you can take the a cubed you just got and plug it into this equation. So I'll take this a cubed here and say 20 plus root 392, that's a cubed, plus b cubed equals 40. And then when you subtract 20 and radical 392 from both sides, you get b cubed equals 20 minus the square root of 392, which makes b equal to the cube root of 20 minus the square root of 392. But x is a plus b. And that's how he ends up with this answer. Notice that that's the exact same answer that we got when we plugged into that Cardano formula. And if you would try to do this generally, and set up the system of equations, 3ab equals p, and a cubed plus b cubed equals q, and went through that entire process, a would become the cube root of q over 2 plus the square root of q over 2 squared minus p over 3 cubed, and b would become the same thing, except there would be a minus here. And x would be the famous Cardano formula. P over 2 plus the square root, that's q over 2, plus the square root of q over 2 squared minus p over 3 cubed, plus the cube root of q over 2 minus the square root of q over 2 squared minus p over 3 cubed. So what you have is a formula for doing this, questions like this. A cubic equation with no x squared term is called a depressed cubic. You have a formula for it, and you have a more lengthy process using this system of equations. I'll recommend that you use the formula and that you try to understand where the formula comes from. An important example of the depressed cubic that's going to come up in a later example is this one. And if you run this through the formula, you would get 190 cube root of 190 plus the square root of 33903 plus the cube root of 190 minus the square root of 33903. Which, just so you know, is not 9, but it's really close to 9. Or specifically, I'm going to write down that it's 9.0098 if we need that much accuracy. To solve depressed cubic like this, that was a big deal when they figured it out in the early 1500s, because for 3,000 years there was not so much progress on cubics. But what if it's a cubic equation that has all the terms? Well, that is not of the form that has this x squared term, and we don't have a method. This Cardano formula only works if there's no x squared term. And figuring out how to do this kind of equation was sort of like the holy grail of math for a long time. Even after figuring this out in like 1515, it took another 30 years to figure out this little trick, although the truth is not many people knew how to do this type of equation because it was kept secret. To show you how to deal with a squared term, we're gonna come back to this equation. Instead, I'm going to show you a strange way to solve a quadratic equation that you won't have ever seen before. Here's a quadratic equation, and we know, because this is factorable, to x plus 4, x plus 2, so we end up with x equals negative 4 or x equals negative 2. So we already know that has an answer. But let's say we didn't know how to factor. What if I were to replace the x with another expression, all the x's, like for instance, replace them all with y plus 1s? Well, that equation looks like it's harder than the original one. And I don't know if it's harder, but it is like just as hard, because if I work this out, this new equation, y squared plus 2y plus 1 plus 6y plus 6 plus 8 equals 0, y cubed plus 8y plus 15 equals 0. Now, if I don't know how to factor, I can't do this equation either, but let's just say now I remember how to factor. And I would get two answers of y equals negative 3, of y equals negative 5. What I want you to notice is that the answers to this equation are one less than the two answers to this equation. Because if negative 4 makes this equation true, then negative 5 should make this equation true, because it's like the same thing. It's negative. If I put negative 5 in for y, this would turn into negative 4 squared plus 6 times negative 4 plus 8. So if it's true that negative 4 squared plus 6 times negative 4 plus 8 equals 0, it will be true in this equation also, but there's a y plus 1 here, so I'd have to put something like negative 5 in, so that when the 1 got added to it, it became negative 4. This idea of replacing x with a y plus something and solving the new equation, and then adjusting using what you get for the new equation to answer the old equation, that's only useful if the new equation, this one, is easier than the original equation. And that doesn't happen when you replace it with y plus 1. But imagine I went back to my equation and instead replaced x with y minus 3. Let's just see, what would happen there. Now my equation would be y minus 3 squared plus 6 times y minus 3 plus 8 equals 0. Well, that looks just as hard as the original. But when I actually start working it out, something very lucky happens. Those 6 y's cancel out. I end up with y squared minus 1 equals 0. Well, that's an easier quadratic equation than this original one. So I could solve it just by saying y squared equals 1, y equals plus or minus 1. But remember, x was y minus 3. So it's plus or minus 1 minus 3. 1 minus 3 is negative 2. Minus 1 minus 3 is negative 4. And those are the same as the two answers to this. So imagine I didn't know how to factor. So I couldn't, or I didn't know the quadratic formula, so I wouldn't have the option of doing this. But if I do this replacement, in this case x equals y minus 3, I would end up with an easier equation to solve, and then I could use those answers to get the answers for x also. In general, x squared plus bx plus c equals 0. If you replace x with y minus b over 3 over 2, I mean, your equation will turn into y minus b over 2 squared plus b times y minus b over 2 plus c equals 0. And when you do the FOIL thing, you get y squared minus by plus b squared over 4 plus by minus b squared over 2 plus c equals 0. But what's key is that these two things will always cancel out. Now, if I have a cubic equation, I can do a similar thing. If I let x equal y minus, now we have to be careful. In this case, watch what happens if I let x equal y minus b over 3. If I did that, and I started to expand this thing out, this thing would end up being y cubed minus by squared. I'm just going to say plus a bunch of stuff. And then this second term would end up as by squared plus a bunch of stuff, and this thing would end up as a bunch of stuff. And what would end up happening is that these two things would end up canceling out, and I would end up with a so-called suppressed cubic, which fortunately I have a process for solving. Let me show you this with a specific example. So here I have x cubed plus 6x squared plus 6x minus 13 equals 0. If I replace x with y minus b over 3, which in this case is y minus 6 over 3, that's b, which is y minus 2, and I replace each of the x's with a y minus 2, and I'm going to want to be really careful with my expanding. Y minus 2 cubed, I'm going to just put on the side a reminder that a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. So y minus 2 cubed is y cubed plus 3 a squared b, 3y squared negative 2 plus 3y negative 2 squared plus negative 2 cubed. Let me just simplify that while I'm here. That becomes minus 6y squared plus 12y minus 8. I also have to do the y minus 2 squared. Well, that one is y squared minus 4y plus 4. And when I simplify that, I get 6 when I distribute the 6 through 6y squared minus 24y plus 24. We still have the 6 times y minus 2. That's plus 6y minus 12. And we got this minus 13 equals 0 still hanging out there. Well, that's a big mess. But the key to this is that the 6y squared ends up canceling out. And this equation turns into y cubed. We have 12y minus 24 is minus 12y plus 6 is minus 6y. And here I have minus 8 plus 24 is 16. 16 minus 12 is 4. 4 minus 13 is negative 9. And this is a depressed cubic. If I move the 6y and the 9 over, it becomes this. And then if I run this through the Cardano formula, so 9 over 2 is 4.5. 9 over 2 squared is 20.25. 6 over 3 cubed is 8. So 9 over 2 squared minus 6 over 3 cubed is 12.25. So that makes this, I'm going to need a little more room for that. Cardano formula says this, q over 2, the square root of 12.25 plus the cube root of 4.5 minus the square root of 12.25. Well, the square root of 12.25 is actually 3.5. So this is one of those that we actually can simplify a little bit further. We get the cube root of 8 plus the cube root of 1, which is 2 plus 1, which is 3. Now 3 is the answer for y, and you could check that. 3 cubed is 6 times 3 plus 9, 27 equals 27. That's true. But the question wasn't about y. The question was about x, which was from this equation. Well, if 3, y equals 3 makes this equation true, so that means when y is 3, y minus 2 is equal to 1. Or you could just say this, if x equals y minus 2, we could just come over here and say x is equal to y minus 2, which is 3 minus 2, which equals 1. And 1 is the answer to this cubic equation. So that's the process. You do your substitution, you solve for y, and then you adjust your answer based on what you get. Okay, one last equation, because this one specifically is going to be important for the next video. Here is another cubic equation. So we replace x with y minus b over 3. I should mention that if there's a number over here, we would divide by that also. So I'm going to say b over 3a. But since a equals 1, which I usually make it, if it's not 1, I usually divide by a so that it becomes 1. But I'm just going to mention that it really is b over 3a, which in this case is 15 over 3 times 1, or y minus 5. So we replace each of the x's and then we try to be very careful in simplifying this thing. And I sometimes go into like a Wolfram Alpha and I type in simplify and I type in this big expression without the equal 0 to make sure that it's right. But if you do this carefully enough, you will eventually get y cubed minus 39y minus 380 equals 0, which became depressed cubic, which means you can move 39y plus 380 here. And this is a good one for using the formula, especially when this number is even and this number is divisible by 3. You would end up with 190, the cube root of 190 plus the square root of 33,903 plus the cube root of 190, that's a minus the square root of 33,903. And we've seen this equation before. If you go back, we saw the same equation before, and we saw that it became 9 approximately, but not exactly, 9.0098. I will get all those decimals in there. So that's approximately 9.0098. Well, that's the answer for y. But this equation here was asking what's x? Well, x is y minus 5. So we could, if we want to have an exact answer, the exact answer, all we could do is go like this. And then at the very end of all this, stick a minus 5 there. And if we have a decimal approximation, it would be about 4, because it's 5 less than this 9.0098. So I'm going to write 4.0098, which is approximately 4. Write that a little better. 4.0098, which is approximately 4. So what I've shown you how to do in this video, I started with depressed cubic equation, and I showed you that there is a formula for it. Then I showed you how that formula came from this process, because these depressed cubic equations can be turned into a system of equations, and that system of equations leads us to the same answer as the formula, and that's actually where that formula comes from. And then I did some examples of depressed cubics, or at least one example, and then I showed you that if you take a quadratic equation, you can replace x with y minus b over 2, turn it to an easier quadratic equation, and then that answer can be used to find the answer to the original. And then I showed you that there's a similar thing for cubics, the y minus b over 3a trick. Why don't I go ahead and put the a there. And then I use it to solve this cubic. And then I use it to solve this one. So this answer is about 4.0098. And this was the process for it. Without a calculator, you'd have to write the answer like this. Okay, so that's everything you need to know about cubic equations. In the next video, I will show you how Cardano explains how to solve fourth degree equations.